Hey guys, hope everybody's having a good day today. So, remember last Friday we talked about vectors and we talked about vector addition and subtraction, scalar multiplication. Well, today we're going to talk about the dot product. So, if you'll remember last week, we went ahead and just defined the vector u as being AB, and then we went ahead and defined the vector v to be CD. We're going to use these when we do our formulas. So, first, let's talk about the formula for the dot product. So it's just the dot product written like this, and the formula is going to be, actually, it's going to look like this. If you just see it in your book or somewhere, it's going to say u dot v. So it kind of looks like multiplication, and the formula will come out from that, and it'll be a times c plus b times d. Okay, so this is just like a normal multiplication problem. So you had numbers in there for a, b, c, and d. So then your answer is simply going to be multiply a and c together and multiply b and d together and then add those two together. So let's do a quick example. So let's say vector u is 2, 6, and vector v is 4, 2. So we want to do u dot v. So first, we're going to take what number we had in A, which is 2. So we're going to write him, and then we're going to take the number we had in C, which is 4. So we've got 2 times 4. Then we're going to take our B and our D. So we had 6 and a 2. So we have 6 times 2. We all know that 2 times 4 is 8, and we all know that 6 times 2 is 12. And 8 plus 12 is going to be 20. So our answer is just the scalar 20. It's not a vector. It's just a constant 20. Okay? Okay, now let's do one that's in vector component form, since we know that there's two ways of writing vectors. So let's rename vector u to be 3i plus 2j. And then let's say vector v is 6i minus 12j. The arrow goes over the I, not the 6. Use a little eraser here. So we'll say 6i minus 12j. Okay, so first, if we want to, we can also write this in component form, so it's going to look like 3, 2, and 6, negative 12, because I know you all like to do that better. I think you realize that that's a little bit easier. So let's take the dot product. Let's find u dot v. Okay, so that's going to be our first in both of them. So 3 times 6 plus our second ones, which is 2 and negative 12. Now 2 times negative 12 is going to be negative 24. So we're going to have minus 12 times 4, or times 2, sorry. And then we'll do that out, and we'll have 18 minus 24, which is going to give us a negative 6. Alright, so let's move on now, and let's find the angle between two vectors. So if they give us vector u and they give us vector v, and they're both in standard position, but they're not the same vector, and say they want us to find theta, which is in between, we're going to have to use a formula. So the formula for that will be cosine of theta equals u dot v over the magnitude of u times the magnitude of v. Now these aren't, the bottom is not a dot product, it's just a times. So you'll take the magnitude of u and multiply it times the magnitude of v. Okay, so now we've got our formula. Let's try an example. So they're going to give us, we're going to have two vectors. We're going to have vector u and vector v, and we want to find the angle that's between them. Okay, so let's say we have vector u, which is 1, 4, and vector v, which is 3, 5. Okay, so now let's write our formula. We know cosine theta equals u dot v over the magnitude of u times the magnitude of v. Alright, so let's find u dot v over here. U dot v. We know we take our first, which is the 1, multiply it by our first in this one, so we have 1 times 3, and we're going to add the second one, so we've got 4 times 5. We know that 1 times 3 is 3. We know that 4 times 5 is 20. So we'll have 23. Okay, so now we have the top part of our equation. We know we have 23. So let's think back to last week when we did the magnitude. We found that the magnitude was the square root of a squared plus b squared. So it's the square root of our first number plus the square root, or plus the second number squared. So let's find the magnitude of u down here. So we have the square root. Our first number is 1, so let's do 1 squared, plus our second number is 4, so let's do 4 squared. So we'll have the square root of 1 plus 16, and that'll give us the square root of 17. Okay, now let's find v. We know, let's find the magnitude of v. So we know we'll have the square root of 3 squared plus 5 squared, because those are our two numbers in v. So we'll have the square root of 9 plus 25, which is the square root of 36, which is going to equal 6. So let's bring this number back up, and let's bring this number back up. So we'll have 23 over 6 times the square root of 17. Right? Now we can simplify this by, actually it's going to be easier if we just don't simplify it. So we know, I'm going to go ahead and clear the page, and we're going to start a new page. So we know that cosine theta equals 23 over 6 times the square root of 17. Okay, so let's just leave it in this form instead of getting a decimal number. So we know from our trig functions that if we want to find theta, we've got to take the inverse cosine. So theta is going to equal the inverse cosine of 23 over 6 times the square root of 17, which is going to be our answer. That's what theta is going to be, or we could find a decimal, but for this case, this will work. Right? So now, there's one special case of the dot product, and that is when we have perpendicular vectors. So say we had a coordinate plane, and we had a vector that went off like this, and then we had a vector that went off like this. We had a 90-degree angle in between them. Those vectors are going to be perpendicular. So we know that a vector is perpendicular when their dot product equals 0. Alright, let's try an example with this. So we have vector u, which we're going to say is 8, 6. And then let's take vector v, which is going to be 3, 4. 3, negative 4. Okay, so let's find the dot product. We want u dot v. So let's take our first times our first. So we have 8 times 3. And then let's add our second times our second, which is 6 times negative 4. So 8 times 3 is 24. And then we have 6 times negative 4, which is also 24. So it's minus 24. So 24 minus 24 is 0. So we know that these two vectors are perpendicular. Let's say we had vector, let's just go ahead and call it vector W. So let's say we have vector W and it equals 4, 3. Let's try taking U dot W. So that would be U's up here, so 8 times 4, and then we're going to add the second one, which is 6 times 3. So we know 8 times 4 is 32, and we know 6 times 3 is 18. If we add 32 and 18 together, that gives us 50. So we know that U dot W are not perpendicular vectors, but we know U and V are perpendicular vectors. So now let's move down and talk about work. So work is defined as force times distance. Let's get this erased so it looks a little better. So we know it's force times distance. So when we have two vectors, it's going to be the vector F dot the vector D. Okay, so let's try an example. Let's say this one is actually number 24 in your books. So the vector F, which is for force, equals 45I minus 12J. Okay, and then the vector D is going to equal 70I plus 15J. Okay, so now let's find the vector F dot the vector D. So we're going to take our first times our first, so we're going to have 45 times 70, and then we're going to add our second times our second, so we're going to have negative 12 times 15. Now, if you have your calculators out, you can do 45 times 70. It's 3150, and then we're going to do negative 12 times 15, which is going to be negative 180. So if we do 3150 minus 180, that's going to give us 2970. Okay, so this is the way that we're going to do work. So the work involved in this problem is 2,970. So that's going to be all that we're going to talk about this week. So I hope everybody had a good understanding about it, and we're going to talk more about it in class tomorrow. Have a good day.